afternoon, one and all. As we all know that the National Science Day is celebrated in India on 28 February every year. This is to mark the discovery of Raman effect by Indian physicist Sir C.V. Raman in 1928. Sir C.V. Raman was awarded Nobel Prize in Physics in 1930. As a part of the Science Day celebration, the Department of Chemistry, Fatima Mada National College Autonomous, is organizing an international webinar on electrochemical sensors and energy storage devices. Dr. Vibhu Manyakal, Research Associate, Bendable Electronics and Sensing Technology Group, Glasgow University, UK, is our resource person. On behalf of the Department of Chemistry and IQAC of Fatima College, I extend a warm welcome to you, sir. I also welcome Reverend Father Anil Jose, our manager, our principal, Dr. Vincent V. Neto, sir, my colleagues, students, and all participants. Thank you. I invite Dr. Namida LK, Organizing Secretary of the webinar, to introduce the resource person.
Thank you, Miss. Good afternoon, everybody. Today we gather here to celebrate the National Science Day. We are celebrating this via an international webinar. The webinar name, that is the electrochemical sensors and energy storage devices. I am very excited to take the opportunity to introduce the resource person, Dr. Vibhu Manyakal. That is, his short bio of Vibhu is already I shared in the group. As part of this, I just take few sentences from his bio. That is, Dr. Vibhu Manyakal secured his graduation from Malabar Christian College and post-graduation from St. Stephen's College, Ujjavu. He obtained his PhD in electronic engineering from Poland with the prestigious Marie Curie Fellowship. And later he joined BEST Group at University of Glasgow in 2016. He is a talented researcher in transparent electronics, advanced energy and electrochemical sensing. He has extensive experience in Marie Curie projects as early career researcher, experienced researcher, and scientific project manager. He has authored around 60 plus articles in high impact journals like Advanced Materials and ACS Applied Materials Interfaces, etc. And he has submitted 3 patents. His widely academic innovations include the thick film pH sensor for online water quality monitoring, sweat-based textile supercapacitor, and flexible graphite composite supercapacitors for prosthetic and robotics applications. It's difficult to mention all of Vibhu's achievements in such a short span of time. I can't skip a very special one. That is, recently BBC's Science Focus magazine selected sweat-based supercapacitor work as future technology, 22 ideas about to change our world. On a final note, he is also a fascinating personality individual, and I am very proud to say that he's a friend of mine. We are all grateful for your presence, sir, with us today. Without further ado, please join me in welcoming Dr. Vibhu, and over to you, sir, for your presentation. And also there is one suggestion, that is, please everybody post your questions and queries in the chat box. The questions will be discussed at the later session. Okay, over to you, sir.
Thank you, Namida. Thank you so much. Thank you so much for the program conveners, program organizers of Fatima Mada College. I'm very happy to present my work today with you. Shall I share my presentation? Okay, so maybe we can talk about some basics and some application of electrochemical devices. This is today I am presenting my work. As Namida said, I completed my PhD in a Marie Curie program, one of the Marie Curie program in Poland, related to water quality monitoring. So today I'm presenting my work related to my PhD, and then after that the major work related to my postdoc during University of Glasgow. Before going to a detailed discussion about my work, as Namita mentioned, I'm currently working in University of Glasgow, one of the research group called the Bendable Electronics and Sensing Technology Group. We are more than 30 members in the group with the supervision of Professor Devendra Dahiya. There are mainly 4 research themes in our group, which is related to mainly we are focusing on flexible electronics for wearable application and also for a prosthetic hand robotics application, including pollution monitoring and food quality monitoring, all related to flexible electronics. We are synthesizing a nanostructured material called zinc oxide or a silicon-based nanomaterial, and especially for flexible electronics application. This is one of our theme called nanostructures based flexible electronics. And then another theme, mainly we focus on sensors and energy, where we developed our own sensors for electrochemical sensors for water quality or wearable application, including wound monitoring fields. And then we have another, and also in this area, we have working on electrochemical energy storage devices, especially supercapacitor. I'm mainly working in this theme, sensors and energy system, and then another theme called biotronics, where we are fabricating sensors for bio application, mainly health monitoring application. We are developing sensors and its related components like wireless communication system or flexible electronics. And then finally, we are working on integration of all these electronic skin into a robotics application. We know that in a prosthetic hand, it needs feel of sense, for example, touch or temperature, or when they touch any chemicals to know the property of that material. Mainly we are working in that area. We are fabricating all these sensors to integrate on the electronic skin to provide a life for the object. So now maybe we can discuss about some of my work. I completed my master degree in physics, but after that I joined in CMET Thrissur. Almost 2.5 years I worked there, mainly material synthesis. Then I moved to Poland, initially Portugal and then to Poland. I did my PhD mainly in electrochemical technologies, where chemistry and physics, electronics, everything combined together. I know maybe there are a lot of master degree students or PhD students or bachelor degree students are attending here today the webinar. Maybe they are thinking about their project for the future project for starting a research. So I must say that electrochemical technology is one of the good area where you can start a research program. Because it is connected to our daily life in many ways related to senses. For example, if you want to monitor the quality of water, you need multi-senses. You need many senses in analyze the pH value, dissolved oxygen, and many chemical parameters are present in the water. You need sensor for that. And also for a wearable application. Nowadays, we know that even though in COVID situation, a remote monitoring of our health including diabetics, all this area, you need electrochemical or biosenses. So electrochemical technology lies in this area. How can you fabricate a sensor for such an application? In addition to this, energy is the critical component in our world, including battery or supercapacitors, whatever the form. For an energy storage, it's mainly lies in, again, electrochemistry principle, and then energy generators are there, including biofuel cells, and also corrosion analysis, electrolysis. Like many areas, electrochemical technology are main prominent. Then you see, among these, I would like to discuss with you 2 areas where sensors and energy storage. This is my major work related to my PhD and postdoc period time. Hello, Namita, can you hear me?
Yes, yes.
Okay. Okay. So you see, there are 2 types of devices I showed here. One is sensor, another is energy storage. So There are many electrochemical sensors, but I know there is a lack of time. So we can discuss today about the pH sensor, one of the basic and one of the major important sensor in electrochemical technology. You know that in pH sensor, we in our laboratory we are using pH sensing by using either by using a litmus paper or by using a glass-based pH sensor. That is the best sensor presently in the world, glass-based one. But when we are using a glass-based pH sensor in many applications, including water quality monitoring or food quality monitoring, uh, the chances of breaking of the glass is very high. And also it is not bendable or it is not flexible. So when we want to monitor our skin pH value or let's consider in a wound, okay, in wound fluid, the wound healing depending on the pH value of a wound fluid. So if you want to monitor in a remotely or in a daily aspect, the wound fluid pH value, you need a thick film based or a thin film based pH sensor. So we need to mimic the exact glass based pH sensor to in a planar technology, either in a flexible or non-flexible. So that is my major aim during my PhD, how to fabricate such a glass based one, convert a glass based one to a planar one for an online water quality monitoring. And then in energy storage, I mainly discussed today about the supercapacitor, one of the recent emerging in energy storage technology, mainly for power electronics application or electric vehicle application. Whenever you require a quick power delivery, one of the best device is supercapacitor. So I will explain both of you, both of these devices, how to fabricate and what are the characteristics. For example, if you are planning to start a master degree program, if you want to fabricate a sensor, what are the sensitive material we can choose? Before that, why? Uh, as I mentioned, you there is an electrochemical technology. Why this is required? We can check that. For example, in a sweat monitoring, diabetic analysis, or another cystic fibrosis diseases monitoring, you need set monitoring sensors. This is Alijave group. Gao et al. Developed a multi-sensory band. In this sensor, it contains multi-sensing parameter using electrochemical devices. And also, we have developed another pH sensor for a stretchable pH sensor for set monitoring. In addition to this, physical sensors also required power, or in electrochemical technology, we need to fabricate devices to operate these physical sensors, including strain sensor for a human-machine interaction or a pressure sensor. This all required power. So how to give a power for these devices? Using a bulky battery attaching on a human skin or a human devices is very difficult, related to toxicity, related to lack of bendability or producing heat. So a flexible electrochemical devices required there to attach all these devices. And in addition to this, all electronic components, to operate all electronic components, you need either power or energy to operate a good span. So all these applications in a, I'm related to wearables, we need a flexible electrochemical technologies. So regarding the pH sensor, you can see how the pH sensing related to our daily life. When you can see this arrow, for example, in a pH 7 in our normal drinking water, if the drinking water pH is increased or due to many parameters, that cannot be useful for our daily life. And also in a healthy skin pH is 5.5, and also our stomach fluid, not only in a human being, and also for animals stomach fluid application monitoring, all this area we require a pH sensor. So we can say that from 1.5 to almost 12 range, we need to measure the pH sensing, pH value of different type of fluids. So there are for this there are many type of sensors, including potentiometric sensors are there, which is similar to a glass based pH sensor, where thick film sensitive electrodes are there and reference electrodes are there. And then a capacitive, it is based on a interdigitated structure or a two electrode system, where to make a reference electrode is difficult in, especially in a thick film technology. So to overcome that issue, there are capacitive based pH sensor. You can see in this figure, initially starting with a different material A, B, C, many nanostructured material you can use like ruthenium oxide, iridium oxide, and then there is a potentiometric sensor. Capacitive sensors are there, and also chemi-resistive based sensors, which is based on again how the when a pH solution influence on the sensitive material, the resistance of the electrodes are varying. And then transistors are there, ion sensitive field effect transistor, also field effect, extended gate field effect transistor. Like this, there are different type of sensors are there in metal oxide, and also in polymeric based materials are also using for these sensors fabrication. I last year I published a review article. You can see all these details about this material in or technology in that review. Again, you see, as I mentioned you see there are in a potentiometric sensor, there are two electrodes. One is sensitive electrode and another is a reference electrode. Sensitive electrodes, normally you can use any proton sensitive material like ruthenium oxide, iridium oxide, or a zinc oxide, but and also zirconium based materials are also there. For a reference electrode, normally we are using in a pH sensing silver chloride KCl reference electrode. You know that it is like a salt bridge. It contains a glass and then KCl liquid is there. KCl is easily dissolvable in water. So when we want to fabricate such a sensor, you need a sensitive electrode, you need a reference electrode. 1 minute, sorry. You need a sensitive electrode and you need a reference electrode. So when we use a KCl paste or KCl in a reference electrode application, when we fabricate such a sensor, you can see here that white color is a reference electrode based on a KCl. When you dip this material in a water, it is easily dissolvable. That means that the lifetime of the sensor is very short because there is no flow of ions between these two electrodes. To overcome that issue, what I did that I prepared a new thick film based reference electrode where a glass based KCl composite printed on the top of this this reference electrode material, and which act as a salt bridge. So what happened is that when we dipped this sensor, the first sensor in water, there is a small ionic path is there. Through that, ions can easily enter into the reference electrode and it easily worked as a salt bridge, and then there is a sensitive material also. So ideally, when you dip this this sensor in a water, with depending on the pH value of solution, the obtained potential difference between this electrode is like in a range of 59.14 millivolt per pH. It is based on an Einstein response. And then this is the sensitivity. This is the ideal case. So researchers and we are aiming to fabricate a sensor which can give an exact Einstein response to predict the sensitivity. It may be very difficult to get such a sensitive material maybe due to ideal value, due to the nature of sensitive electrode or the stability of reference electrode. So there are many material reported so far in this area. So for example, if you want to, if a master degree student, you want to, or PhD students want to develop a new pH sensor, you can check all these type of material. For example, if it is an iridium oxide, it shows a super Einstein response. It depends on how the number of electrons, how many number of electrons involving in this electrochemical reaction. There are iridium oxide material and then ruthenium oxide. I found that from this iridium oxide, ruthenium oxide, TaO2, you can see here this central bar theoretical value 59.14 millivolt. This ruthenium shows almost near to that ideal Einstein response in an average aspect. So due to it is the excellent ionic and electronic interaction of this ruthenium oxide material and a very good catalytic material also ruthenium based electrode shows an excellent sensitivity as compared to any other material. But the problem of ruthenium oxide is it's very expensive and also toxic material for a large application. So now researchers trying to overcome this ruthenium oxide by using a new material like a zinc oxide or another tin oxide based material. What I did that to reduce the cost of this material, I used a binary oxide, ruthenium with other tin oxide or tantalum pentoxide, binary based composite, prepared binary based composite to overcome this issue, and which also observe almost an instant response. Then, if you want to fabricate such a sensor, there are different methods. For example, screen printing are there, sputtering is there, and then electrode deposition is there. Sol gel methods are there. Uh, uh, Depending on your convenience, you can fabricate. For example, screen printing is a large. For example, if you want to make a large area or a large scale production or an industrial application, you can use screen printing method. And then sol gel methods are the like spin coating or a dip coating. In a simple method, if you want to fabricate, you can make your own solution and then spin coat or dip coat on the electrodes. That method is also very good for uh, application, large area application. And then if you compare different method, you can see here screen printing shows almost excellent performance in terms of sensitivity. When I compare many papers and I observed all this data, I collected this data from the many papers, and then I found that since in terms of screen printing, it shows it's a thick film as compared to thin film, so large amount of materials are required, but cost-wise or a miniaturization or easiness of fabrication, multi-sensor fabrication, screen printing is one of the best candidate for in this aspect. You see, in back in our place in Kerala, there are a lot of rivers or aquaculture medium are there. So it's a very good opportunity for you to develop such a sensors in wide application, because you can implement in many areas in our field. When I'm doing my work in this area, what I did that I made this binary metal oxide based sensor by screen printing technology, and then I use collected the water from the river in Poland, and then I tested the pH sensor, pH sensitivity value of that water. Then I found that if it is related in industrial area, there are more pollutant. So you can easily predict the pollutant of that water by using this type of sensors. Here, there are many sensors which I developed during last few years. You can see here, I started with a thick film one. Come here, you can see a glass-based one also. Compare with a thick film, a glass-based sensor. You can just imagine. You see, a quality of a meat. If we are eating meat, in all type of meat. If you want to check a quality of a meat, one of the important parameter is that pH value. If you use this glass-based pH sensor in a big industries where they are exporting the meat, and initially they are testing the quality by measuring the pH value of the meat. When they insert this glass, due to this breaking nature, that the glass particles are spill over the meat. So it is not useful. So what they are now trying to use that like a thick film based sensor. When I developed this sensor, one of the industry in Estonia, we are testing, we are collaborating with that industry, and we are tested for their application to monitor the pH value of meat. Then we found that in a meat content, there are many other parameters like fatty acid, fatty composites. So that may influence on the sensing performance. So now research is focusing on in this aspect how to overcome all those interference influence of the pH sensing. So if you are planning to fabricate a sensor like a thick film based devices, you can check all other parameter, how they influence on the sensing. If you overcome all this issue, that will be a very good sensor for a commercial aspect and also a research point of view. So here there is a reference electrode. To overcome that, I developed another interdigitated. It's contained like an interdigital electrode and then sensitive material on the top of that. Then what happened is that when a pH solution coming on contact of this sensitive material, the electrical property like capacitance, inductance, or resistance, impedance may vary, depend on the pH value of solution, because then solution contain H plus and OH minus ions. Depending on that ionic concentration, the electrical property may vary. Based on that, we can fabricate a thick film based sensor. And then I developed for a online water quality monitoring. Sensors is not enough. We need related components also, like microcontroller chip or for programming all these applications. So to embed that all electronics in a single package, what I did that I developed an LTCC technology. You maybe majority of the you know aware about this technology. I fabricated a chip-based sensor like a pH sensitive and reference electrode. Then my colleagues, as a remaining part, my colleagues developed that electronics part, and we integrated that with that sensor, and then for a wireless application. All this material are fired in are here when we are fabricating this material, we need to get a good adhesion on the substrate. So we used a 900 degrees Celsius to get a good adhesion and a material forming. Uh, but when we coming to a wearable application or where we need a conformable surface, when we need to apply, attach a sensor, we need flexibility is the major factor. So what I did that I made a flexible reference electrode that you can see here, replica of this thick film reference electrode or a glass based one. And then in collaborate with one of the research institute, NIT NIT Trichy in India, I developed another flexible sensor, pH sensor on a CUM based material. And then here supported one of the PhD student. She developed a, this is rigid and then flexible. And when we attach in our human body, for example, if you want to attach a sensor in our human body, our human body is highly stretchable. So when we are running, it may be not only flexible, there is stretchability also an important factor. So we made a stretchable pH sensor, pH sensor. And then finally, such a sensor to attach on a human body may be difficult. Maybe we feel itching or issues. To overcome that, recently developed a sensor on a cloth. So in a wearable, in our wearable application, we can easily make the sensor, and when we are running due to sweat, uh, it gives the pH value, and we can monitor using our mobile phone. Here you can see some of the flexible, how can you fabricate, for example, a flexible reference electrode. If you have a substrate like any plastic or polymer substrate, you can print conducting path here, and then one end of the conducting path you can convert into, because you need silver chloride. This is a silver electrode, and then convert silver into silver chloride by chemical treatment. And then on the top of that, a KCl paste printed, and then covered with a insulative material. The whole part is this. And then I measured this with different commercial glass devices also, and also under different bending conditions. And here is another flexible nano copper oxide based pH sensor. For example, if you want to monitor in a wound monitoring application or all this area, nanostructured material, biocompatible material is highly required. So again, it depends on, because you know in pH monitoring or in electrochemical application, we are monitoring the ionic changes. So as a sensitive material with a very good surface area or a porosity, maybe will give you a very good performance. For example, I used a CU nano flower like structure or a nano rectangle based structure to fabricate those sensors. And you can see here, these are some of the studies like impedance spectroscopic analysis, electrochemical impedance spectroscopic analysis, and then a flexibility application. This is another work which I collaborate with the US, one of the university in US. We recently developed an electrode deposition method. We developed an iridium oxide material and then fabricated a pH sensor on a flexible substrate. So here you can see here in a wearable application. So not only sensor required, related to sensor, we need a communication part also. So if you are a very good electronics engineer, or you can collaborate with any other research institute, you can make your own program. So when you are running, you know that there is a smart watches in Apple, or many industry, any companies are introducing smart watches to monitor our health parameter. We also developed a pH sensor to monitor our health parameter like a sweat solution through our mobile phone. You can see here there is a stretchable pH sensing electrode is there, and reference electrodes are there, and also RFID antenna, stretchable RFID antenna, and with a data transmission circuit is there. And then you can see here, we are this video, you see there is a pH solution. That solution is, we made a set equivalent solution in our lab. We can use some chemicals and we can easily make the solution. And then we insert our pH sensor in that solution. And then during when the pH value of solution is changing, you can see here, we change the pH value. Here in the phone, you can see there is a, depending on the pH value, there is a potential difference variation that you can snapshot. You can see here, there is a pH variation depending on the pH value of set. So a similar approach you can do for another sensors also. For example, a glucose sensor. You need, if you want to make a diabetic monitoring, if you want to measure a glucose level, you can make those sensor. And then you see, as I mentioned you, in a pH sensor, not only sensitive sensor is required, we need another component also. For example, there may be lack of setting. Depending on the physiological status of a person, amount of set may be varying. So if you need to get more sweat, there are method called ionotophoresis electrode. And also, if there is sweat is not lack of flowing in a microfluidic channel, you can use that one. And and the material like a cellulose or absorbent, you can absorb more amount of set into your pH sensing electrode. And then also communication part, you need wireless system, flexible electronics, all this one, and then sensing up, all these required. Also, you can apply this for a skin monitoring, wound application, or hydration in a centralized healthcare system. All this, one of the important parameters is power supply. So initially, my all work is focusing on the pH sensing, and but when I reached into a point of application point of view, I noticed that power supply is a very big problem. Until that time, I used either a battery or a big voltage source. Then we started with different energy sources. You can see an overall energy system technology presently available, and this is one of our review article. For example, there are different type of energy harvesting, like chemical energy, micro fuel cells, or enzymatic BFC, biofuel cells. And then thermal energy is there, like a thermist, in a wearable thermal energy harvester is also there. Mechanical energy like a triboelectric, piezoelectric, electromagnetic, and then solar cell. So all this produces very good energy, generate very good electricity. And to store that, one of the best key parameter is lithium batteries that is widely using now. There are lithium batteries, and then supercapacitors. So these are the two type of energy storage devices. In supercapacitors itself, there are many classification. I will show you what are those classification. And these energies, maybe we can apply in a flexible application like a self-powered electronic skin application. You can see here skin on a contact lens or a energy autonomous tactile skin. This is one of my colleague. He developed this technology and for a tactile sensing application. And then thermoelectric nanogenerators are there for healthcare application also. There are different type of self-powered e-skins are available. You see, today I will explain more about the supercapacitor. I'm very happy to share you this slide because this is one of my major work now. And moreover, that 2 days back I listened our chief minister one of the talk. He mentioned that in Kerala we are starting a supercapacitor industry. And it is really a very good initiation because you see, currently electrical energy or energy requirement is huge. Especially there are many portable devices like mobile phone, not only mobile phone, in wearable application or in a electric vehicle. You need a very good energy source. Currently, we are mainly depending on lithium battery because the performance wise. And also there are zinc batteries there, lead acid batteries are there. So in terms of energy density, in terms of performance, batteries are the best because of the electrochemical reaction or a redox reaction and the material properties as well. But the issue of battery is that one is toxicity, the material we are using. And the lack of material is also going to be a big problem because we are depending on mainly lithium or nickel or cobalt. So in future, maybe there is a shortage of this material. Another major problem, the heating, because due to this electrochemical reaction or this Faraday reaction, it produces, we know that our mobile phone itself. And whenever we require, for example, when we accelerating a vehicle or operating a motor or actuator, you need a quick power delivery. Currently, we are taking those energy from battery. So the battery life cycle is very less, and it easily the charging, we need to charge in more than 1 to 2 hours to get a full charge battery. So to assist that battery performance, um, a quick power delivery, supercapacitors are the best candidate. For example, there are electrocatalytic capacitor like our normal capacitor. We know that in a normal capacitor there is a electrode materials are there in between, a dielectric is there. Depending on the polarization, it produces that electric field produces, and it store the charge, and there is a capacitance. If you want to increase the capacitance of a normal capacitor, when we studied in our basic classes, it required a large area of dielectric material for a 1 farad capacitor. Uh, as the electronics are miniaturized, it is not possible to get such a large area. So there are many research focusing on how to reduce that using different type of dielectric material and a thin film technology or nanomaterial one. One of the best option is electrolyte based supercapacitor because of the dielectric. It's act as the electrochemical double layer formation act as the dielectric, and the storing of energy or storing of the charge is huge. Then electrochemical double layer capacitors are there. Initially, it is fabricated using a graphite or a conductive material, mainly graphite. And there is no electrochemical reaction like an electrostatic interaction. Ions are stored on both sides of the surface of the electrode. But the energy density of those devices are very low. So there are many work going on in asymmetric supercapacitor like a metal oxide based one to improve the performances of the supercapacitor. So if sorry, if any one of you in a master degree project want to develop a very good research article, because I know many of you are now looking forward a fellowship or a project or a PhD position. So it is not easy, you know. You need to get a very good project in your master degree level. With a good publication is very highly advantage. I will show you why it is required in last slide. Uh, so you need to start a very good project. I must say one of the best way you can develop a supercapacitor because it's a simple way. By using your by reading more, by getting more details about knowledge about the material, you can easily change the electrodes fabrication or the electrode property, and you can improve. See, a supercapacitor, when we hear this, we think that okay, it required large amount of time to develop, or it is very complicated system. It's very simple. What you need that you need two conductive material, like our graphite, or using our pencil graphite itself, you can make a supercapacitor. You need two conductive material. In between, you need a dielectric or a separator. A separator may be like an ion permeable membrane, like a cellulose cloth or a polymer film. Okay, and then you need a ionic liquid like our salt solution, sodium chloride or a sodium hydroxide, acidic, basic, or neutral. Any solution you can take. So you have two electrode, in between there is a separator, and you drop your solution and you close this each other. So this conductive electrode and this conductive electrode is not touching each other due to this separator. So when you applied a potential, what happened is that depending on positive or negative voltage you apply, the ions are separating each other and it store on the surface. So this is the basic one. So what you require for to fabricate? You need a substrate like a flexible. If you are, I'm talking about flexible one, like a PVC, polyvinyl chloride, or a PET, textile, Ecoflex, any substrate you can take. And then on the top of the substrate, you need a current collector. So there are a conductive material like a aluminum sheet. Normally you see this aluminum sheet in our food packaging. Also many areas we are using this aluminum sheet nowadays. And graphene or a gold film or nickel foil or copper sheet also you can use. Stainless steel is the one of the best one uh, to make a current collector. You only one consideration, it should be highly conductive and stable in any chemical environment. Okay, so you need a current collector, and then on the top of the current collector, you can print or you can spin coat or drop cast or you can by hand print your active electrode. You can make a carbon nanotube or any conductive polymer or metal oxide. A similar configuration on the other side also, and then you need an electrolyte, acidic, alkaline, organic, any electrolyte you can use. And then you need a separator, as I mentioned you, that is polypropylene film, polyester cellulose blend cloth. And then finally, you can insulate. So like you can package using a PDMS or any for application point of view. So this is what you required. And then you have, if you applied a potential between these two, as I mentioned you, there are charges stored in the surface. And then this is the important point where you want to evaluate the performance of supercapacitor. So in the yellow color, these are the major parameters like specific capacitance, operating voltage, equivalent resistance, equivalent series resistance. So specific capacitance means how much capacitance stored in this device. You can measure this by using charging, discharging. There are different tools, and also electrochemical impedance spectroscopic analysis. You can or CV analysis. You can measure this. CV means cyclic voltammetric analysis. You can measure the specific capacitance. Don't worry, it is if you, I'm talking to the students, if you are reading a good journal article or some journal article, you can easily understand these parameters. And then the specific capacitance depends on the type of material which you are going to use in this fabrication of the device, like electrode density, electrode thickness, porosity of the material. And then you have an operating voltage. Operating voltage is that, for example, if you want to operate an LED, a single LED, it requires above 1.5 voltage. So by using our battery, normal battery, you can operate your LED. But for a supercapacitor, sometimes it operates in less than 1 voltage. You cannot operate this device. So what you need that maybe you need 2 or 3 device or change the operating voltage of the supercapacitor. So you can tune this by using different type of electrode or electrode configuration. These two are the major parameters depending on the operating voltage. So this one operates capacitance and operating voltage. You know our basic equation, energy is equal to half CV square. C is capacitance, B is voltage. So depends on C or depends on B, we can improve our energy density or power density. And again, one of the crucial parameter is the, as I mentioned you previously in the figure, you need a current collector or active electrode. That resistance is very much influencing on the performance of the supercapacitor, and also the electrode electrolyte interaction. It offers a resistance for the device. So if you are planning to fabricate or if you are planning to study about the supercapacitor, please check this review article, one of the good review article. There detailed information regarding the parameters which you require. And then this is some of the basic thing. These are the three major characterization we are doing for a electrochemical supercapacitor, like a supercapacitor. Like the first figure talking about EAS analysis means electrochemical impedance spectroscopic analysis. If your material touching with a solution, what is the resistance, and all these parameters you can monitor from the impedance spectroscopic analysis. And then there is a EDLC for CV analysis. EDLC means electrochemical double layer capacitor, where we fabricate our supercapacitor using a graphene or a conductive material. When there is no electrochemical reaction, when you measure CV, cyclic voltammetric analysis, you observed like a square shape. And if there is an electrochemical reaction, depending on the oxidation or reduction, you observed a pseudo capacitive material. This is mainly depending on metal oxide or a polymer-based devices. And then a battery type reaction, you can strong redox reaction you can observe here. And depending on the type of the material, this is charging discharging GCD analysis means when apply a constant current, you are measuring your potential stored charge in the devices and you can measure your charge discharge. So from these three plot, you can analyze EAS, CV, GCD. You can analyze your supercapacitor. Again, this analysis of this plot is also not complicated. You can easily do this and then you can measure your capacitance or energy density or power density of your devices. So now we can talk about, as I mentioned, there are some basic devices, basic configuration, and these are some of my work. Maybe I can simplify this more. For example, recently I developed one supercapacitor in a pH sensing application. Because I have a pH sensor attached on a body, I need to apply a 24 hours power to operate that sensor. So for that, what I did that I developed a new supercapacitor called GFSC. GFSC is the graphene form-based supercapacitor, and then this supercapacitor integrated with a flexible solar cell. So solar cell harvesting energy and stored in this supercapacitor and delivered to the pH sensor. So this is a flexible power pack. And then in another supercapacitor, for example, in a wristband or in a prosthetic hand, it contains a lot of motors or actuators. So I need more power requirement to operate those devices. So I developed another supercapacitor based on a graphite polyurethane, and then in wearable application using sweat, and then a food quality monitoring, developed a jute bag based supercapacitor, and I can explain you later. Okay, this is one of the case studies. You can check how can you fabricate a supercapacitor, which I followed in my work. This is my first pH supercapacitor in this area. So I have a flexible substrate. And then on the top of flexible substrate, I attached a binder, like adhesive material, any adhesive material, non-conductive adhesive you can use. And that binder attached, I used that binder to attach a aluminum sheet or a graphene sheet. I used a graphene sheet, and then here I drop casted a silver epoxy. This itself, this device, this electrode itself, you can act as a supercapacitor performance because of the reaction of silver. And then a 3D form, mainly in supercapacitor graphene, a planar graphene sheet are using. The problem of graphene is it's hydrophobic in nature. And so you need a better electrode-electrolyte interaction. So form-like structure is one of the best option. So I made a graphene, I used a graphene form here, and then a separator, an electrolyte. And you can see here the graphene form is like a network of structure, and then porosity I also mentioned. As I mentioned you, due to the porous structure, graphene form, when you drop an electrolyte, here you can see, when you drop an electrolyte, it's very slow. You can see it easily distributed around the graphene sheet, graphene form. So there is a better electrode-electrolyte interaction, as you can see here. In each corner of the graphene form, there are positive and negative ions from the liquid are distributing. I used phosphoric acid as a liquid. And then you can see here, when I applied a potential, positive and negative ions are separating each other. And then it forms a, depending on the performance, I measured the CV, as I mentioned in the previous analysis. Because here, even though I used a conductive material, there shows a strong redox reaction due to the presence of silver in the film. And then here you can see EAS analysis and GCD analysis. I'm not explaining you in details about this graph. Then what I did that I finally integrated this with a pH sensor with a GFSC and a solar cell. And then I characterized the solar cell performance. As you can see here, one of the application what I did that here I have a pH sensor, and then in bottom that table you can see here there is a graphene form supercapacitors are there. and depending on changing of the pH value of solution, you can measure the performance of the sensor. And the sensor is powered by using the supercapacitor. This is the another one, another supercapacitor. I prepared a new graphite polyurethane based composite. See, you can easily make this in your lab also. Graphite is cheap material. You can easily purchase that one. And polyurethane is a binder which you can process in 80-degree. Polyurethane normally using in our in a furniture application or polishing application. And it's also in in our kitchen we are using that scrubber, that polymer, that yellow, that scrubber. It is also made on polyurethane. So polyurethane is widely using. So take as a binder, and you can mix with because it's a very good ionic conductive material also. So what I did, that graphite polyurethane binder, I prepared that and I printed on the top of the graphene sheet, similar like previous one, and then stack such a 2 electrodes, and then drop an electrolyte and packed by using a polyurethane layer. You can see here, I dropped that water liquid on the top of a graphene sheet, and then graphene polyurethane composite, the newly made composite. You can see here, when I drop in a normal graphene sheet, there is a water drop like an hydrophobic nature. And when I drop it in a graphite polyurethane, it's highly distributed. And this material I used the first time as the supercapacitive electrode material, and we patented this technology. We filed the patent for this application. And then you can see here, there are I compared this with a different type of supercapacitor, like a graphene sheet one and graphite polyurethane one, and a layered one also. And there are graphene one, and you can see here, and depending on the potential, ions from the phosphoric acid distributed around the electrode. And then compare the different supercapacitor, and you can see here GSSE and GPUSE. GPUSE means graphite polyurethane devices, as compared to GSSE shows a very high capacitance. You can see here pure graphene 1.59 microfarad, but when you have a graphite polyurethane composite, you got a high performance like a 30 millifarad. Then this is mainly for a flexible application. And you can see here, I attached the device on a too rigid platform and applied it. The motor is moving, and then you can see here the device is bending here. And depending on the bending condition, I noticed that this is a less influence on the cyclic bending. During cyclic bending, the device performance, you can see almost a stable performance I observed. That means that you can use such a flexible supercapacitor in any flexible application, any cyclic bending applications. And then for a static bending also, I monitor the devices, as you can see here, different bending radiuses. And then finally, what I did, that you see here, that green color boxes, I inserted that supercapacitor, and then solar cell. I have a solar cell. Using that solar cell, I powered that supercapacitor, and then you can see I connected to an LED. 84 LEDs are here, and you can see in a UOG, our University of Glasgow, with a short period of time after we fully charge the device, it is suddenly give the power to the LED operating. You can imagine that in our wearable application, pulse oximeter, that in that devices required a power which is operating similar to an LED. So you can apply your device in that application. And also you can see here, in a conformable surface, for example, when you want to rotate a motor or a fan, here the device is attached on the column of the this device, and you can see here. And then after fully charging, almost 3 volt I charge in this device, and then I power to the motor, and it is giving a quick power to the device to operate. And then finally, what I did, that in our laboratory, we are developing prosthetic hand. My colleagues are developing this prosthetic hand. For example, if a person due to an accident lost his hand or a palm area, we are fabricating using a 3D printing technology. So this is a hand, okay, and in our hand, we know that our fingers can easily move. Similar way, in a prosthetic hand, it's a polymer or a plastic material. We need to move that fingers. And also, our human body is a very sensitive skin. It's a large sensor actually. So we can, when we touch a small object or a hot object, we can easily distinguish. But in a plastic material, it is very difficult. So we need to apply a sensor on the top of this prosthetic hand. So in our group, we are making this type of sensors. So what I did that I need to operate the motor, which is operating around 5 volt, more than 5 volt. And what I did that we have a solar cell here, and then a supercapacitor attached on the bottom. And then you can see here, when we apply the power, this motor is moving, and then it hold an object. So for operating you can use any object, and then for moving this robotic arm. Now my next aim is, here I am moving 1 or 2 motors only. In a long-term application, it requires a very high energy density supercapacitor, so a flexible one. So this is a very good opportunity for you if you can develop such a high flexible, high energy density supercapacitor which can power a device more than 24 hours continuously without self-discharging. You can be a very good it can be a very good commercial opportunity also in terms of many applications. I think the Kerala government new initiation will be a good point towards these areas. And you can see here, I attached this supercapacitor like a wristband for operating an LEDs, and also the various figures which I used. One of the issue I noticed here, and also in many of the supercapacitor, we are using phosphoric acid or acidic or alkaline electrolyte to operate these devices. But when we coming to a point of human or a wearable application, these acids, when it's break, it may create our skin itching or skin diseases, many other diseases also. So then I was thinking about how to overcome these issues. Then I found that when I working on a sweat-based sensors, sweat contain huge amount of chemicals. More than 90% is water, but in that water is a polar solvent. In that water, there are many ions like sodium, because you know that there is a salt present in our sweat, potassium, calcium, glucose, many parameters. It's a pair of chemicals are present in their our sweat. So more than 80% of chemicals, sodium ions and chloride ions are the major chemicals. In a supercapacitor, I mentioned we need a positive or negative ions from the electrolyte. So I thought, why not we can use that in our sweat contain, sweat is an electrolyte, like sweat contain positive and negative ions. Why not we can use those ions to operate the device? But in that cases, our supercapacitor need to be very highly absorbent, because when we wear the device, the sweat easily need to distribute. So you know that when we are running, our cloth is easily wetting. So I designed a new supercapacitor using our cloth. So I took a normal cellulose, like a tissue cloth. And you know that tissue or cellulose is not conductive material. So we need, in a supercapacitor fabrication, we need a conductive material or an active electrode. So what I did that I drop casted P.PSS. P.PSS is a polymer. It is highly conductive, and that polymer convert the cellulose into a conductive cloth. And after 70 degrees Celsius, it is easily distributed on both sides. And then one end of the conductive cloth, I used a silver paste, because there are many chemical reactions occurring on this cloth, and those ions we need to take outside, or we need to power the device. So for that, an electrode is attached and then insulated. Such you can see here, normal cloth and P.PSS coated cloth. And this, you see in a cloth, there are many fibers. You can see a single fiber, how the material is distributed, how the P.PSS is distributed on the cloth. And then you can see here, there are two such an electrode, as I mentioned you. And then a separator, again I use a separator like a cloth, and then this separator is wrapped around the electrode. So when you attach your body, what happened is that separator absorb our human sweat and distributed into the electrode. So when you applied a potential, depending on the polarity, again, the sweat ions, it may be positive ions and negative ions separated around. And then you can see here, depending on the type of the electrode, I used a P dot PSS. P dot PSS is a highly conductive material. So due to its conductivity, what happened is that there forms an electrochemical double layer that you can see here. But P dot PSS is a conjugated polymer. There may be some redox reaction also. That also I noticed that. So there is a redox reaction in the P dot PSS. To get a P dot PSS pure conductive, I used a DMSO to modified P dot PSS. Actually, this is. And then you can see here the device configuration. It contains sweat ions and then P dot PSS cloth. And this is a very small device, like a 0.5 centimeter width and 1 centimeter length. You can make your own, depending on your size. And here, and it is due to cloth, you can see it is easily flexible also. Then initially I started with a sweat equivalent solution in my laboratory, and then I measured the performances. We measured the performances, and then a human sweat as an electrolyte, and then I compared the performance like CV, EAS, and GCD, and I observed that you can see in a human sweat, without when we have this electrode, there is no sweating. Means it's a dry condition. It's like an open circuit condition, and the capacitance of that device is picofarad. Means that there is not much ions are stored on the surface. But when ions are when during sweating, when ions are take part in the electrochemical reaction, the capacitance is increasing due to storing of the ions. And then I measured the specific capacitance, and I found that both devices, sweat equivalent and human sweat, almost similar performance. Then maybe question will come. See, I'm sweating not equal to other third person is sweating. Maybe the amount of sweat or the volume of sweat may vary depending on our exercise or our health condition also. So what I did that I took initially a 20 microliter and a 50 microliter and 100 microliter. And you can see when amount of volume of sweat is very low, depending on the size of the device, okay? Here I took a almost 5 centimeter square area device, and then depending on the size of the electrode and depending on the volume of the electrode, I noted that when you have a very good volume of the sweat, it gives a very good performance. For example, in 100 microliter, it easily distributed around the electrode, and the device shows a very good current density and performance. Then there is a question. You see, in our cloth also, the sweat may evaporate very fast, depending on the weather or our evaporation rate is very high. And so what will happen after the sweat is evaporated? So what I did that I drop a human sweat, initial cycle, you can see here the performance. And then after 4000 cycle, I noted that there is a voltage. Even though I started with 0.8 volt, I noted that it is jumped into 0.7, almost 0.7 volt. Then it is due to there is a voltage drip in the device. Then I stopped the device and I checked the surface of the electrode, and I noticed that initially there is a very good amount of sweat is distributed, but after long time measurement, the sweat is evaporated, and then it stopped almost working. Is not good as initial. Then I again dropped the electrolyte on the top of this device. Then I found that even though you again drop, there is enough amount of sweat due to electrode property. Electrode property varied after 4000 cycle. The performance is also varied. You can see the P dot PSS is easily dissolved in water. So the material property is very important to get a high performance. So if you are planning to fabricate any supercapacitor in this area, like a human sweat, you can play with a different type of active material. You can use different metal oxide and then react with the sweat how the performances. I measured with the P dot PSS and also graphite CuO. In this work, a short description I given in graphite CuO and detailed description I now presenting in another paper. So you can see here in different bending radius, different volume of set, how influencing on the performance. And then as an application, again, I connected with the solar cell and the supercapacitor, and in a real time performance. You can see here one of my colleague. You see he in his chest, that white color, that is the supercapacitor attached using a cellulose tape, a tap, and then I measured the device when he is setting, and you can see here it is giving an excellent performance in a real life, in a real human set when it's coming into a picture, and depending on the exercise condition. And then again, this is on the top of our cloth, and then my another colleague Namida know this person very well. He is her colleague also previously, Abhilash, and we are together in this work. And he, in this case, he attached the device on his body. So on his chest, we attached the device, and then during exercise, we measured the performance, and then we noted that you can see here inside his body, we attached the device, and then you can see here when during sweating, during exercise, when there is a sweat, your device is working very well, and this there is a drip. It is due to the electric connection. Okay, then such a device I used for monitoring our human salinity monitoring, like a sensor. I fabricated another sensor. We fabricated a sensor and then power by using this supercapacitor. This is the recent work which we reported in recently. You can see here, as I mentioned you, any material you can start, and I proved that also. You see, this is a jute fiber. We know our in our place chakunule is easily available. You can use any fiber for this, okay, for the fabrication of the device. What you need that in our normal fiber is non-conductive. You need to convert that. I took a jute fiber and then convert that jute fiber into an electrode by using P dot PSS. And then such a two electrodes, I stacked it together, as you can see here, and then drop an electrolyte, a gel-based electrolyte. And then when I applied the potential on that circular fiber, depending on the polarity, you can see here Cl minus or K plus ions are distributing. This act as a supercapacitor. And then I made a sensor. We made a sensor. You can see the jute fiber. Jute fiber we converted into conductive jute fiber using P dot PSS, and then electrode. And this is a temperature sensor or a humidity sensor. You can see here in a jute bag. We attached the solar cell here, and then there is a lengthy one supercapacitor, and then a temperature sensor. You can see here. When we applied a temperature on using a hot plate, you can see a hot gun. I applied a heat on the top of the see, I am applying a heat. When I applied a heat, the resistance is varying. And for the operating that sensor, I provided the power from the solar cell and the supercapacitor. So the advantage of such a device is that in a food packaging, you know that food spoiling, there are many issues related to food spoiling due to bad monitoring condition or a bad condition. So you can monitor by attaching an individual sensor on the top of a food pack. Not only food pack, many application you can use this type of devices, and it is more biocompatible, sustainable material also. You can easily make. Here a comparison of wearable and flexible energy storage devices. Initially, I started with a graphene sheet-based device, graphene foam, and you can see here, as compared to other work, our work gives a comparatively good performance, and we published this in 2018 Nano Energy, and the UK Electra for Industrial Award. This work got a Best UK Industry Research Category Award. And then in a graphene sheet-based supercapacitor, it's published in 2019, and then we, for this to commercial opportunity, we got an IQR grant to innovative fund to check the commercial opportunity. And this is the last year work on cellulose cloth. This we again published in advanced material. You can see that as compared to reported work, our performance is not that great because of the material. Further, you can improve by using different type of material. You can enhance the performance. These are the summary of my major work. And before I am going to finalize my talk, after you announce this talk, one of your student, I am very happy. I think what is his name?
Bartholomew.
Yeah, Bartholomew. Uh, he contacted me. I'm very happy because I presented many places, webinars, and presentation. But after that, after presentation, many students contacted how to do this project, how can we collaborate, how can I improve my work, all this. But the student contacted me in LinkedIn and sent a message, sir, I want to, after a master degree, I want to join a PhD. What are the possibilities? I like his attitude because many students are shy to ask. So I mentioned him, okay, I will include those in my presentation. You see, uh, I know there are in India, there are many fellowship, many opportunities you can explore. So there are many classes you may aware about this. I would like to show you some opportunities in Europe, mainly you can apply. For example, if you are completed your bachelor degree, if you want to do a master degree, here mainly in UK, there are 1 year, first 1 year master degree courses are there and 2 years master degree courses are there. Majority of them are 1 year courses. Okay. And it's a huge amount of fees also. It's not, means as when we compare in our money, our rupees. But there are very good opportunity. You can get fellowship also. So half of your course fee would be covered with this fellowship. For example, almost 10 lakh of rupees you can get. This fellowship are like a Commonwealth scholarship. There are many students from Kerala, I know personally also, are getting this type of fellowship to do their master degree in UK. So for that, you need a very good bachelor degree, physics, chemistry, or any subject with a very good score. Try to avoid all supply on everything, because when they cross check your profile, if you show very good academic background, this is purely based on your academic background, you can get this fellowship. You see, there are number of students are applying for this fellowship. Even students may have 99 percentage or 98 percentage of marks are also. So you need to compete with those students. So always, in my opinion, what I found that think about a very good project in bachelor degree also. For example, one of the person from Thrissur, okay, he got a master degree in here in a chancellor fellowship, the bottom one. And he told me that I completed bachelor in technology BTech with a very good project that helped me to get this fellowship. So if you in a BSc, we know that in BSc or BSc time, we don't have much project, but I know Fatima Mother College from Namida, you are doing research also, very good research. So if you can start a very good project during your bachelor degree, that will help you to get a very good fellowship. And also in addition to this, there are Erasmus Mund's joint master degree programs are there in Europe. Like 4 countries and involved in this project, like you can 6 months in one country, 6 months in another country, depending on the type of scholarship. You can 2 years of programs are there. So regarding after master degree, so after bachelor degree, many students maybe in the class there are 50 students maybe. In master degree, number of students are decreasing, and only few of them finally, okay, I would like to do a research. There are many opportunities like in India, SRF, JRF opportunities are there. But in Europe, I must say, there are many fellowship or many opportunities available in many research laboratories. What we need that we need to find it. We need to check. Like the student he contacted me, ask a person who is working in abroad. Sir, or just call their name. It's no problem. Is there any opportunity, any PhD vacancies? available in your laboratory, I would like to do in this topic. Okay, so I would like to do in this topic. I will tell you what is the topic, how can we attack on that. And also, you can see there are many vacancies in like a Marie Curie program. After I completed my master degree, I was almost 2.5 years searching for a PhD. Even though I am started in a project, I struggled a lot to get a PhD position because of many parameters. The way of explaining my experience or to get a position is very difficult. It is not easy. Okay, you need to try hard. And finally, I got my Marie Curie program. Okay, this is one of the best scholarship which is available now in the world. You will get a very good amount of salary. It's like a job. It's not a PhD fellowship. It's a job actually. But you can do your PhD. It's a 3 years program. It's called Marie Curie Early Stage Researcher. So when you search a vacancy like in a jobs.ac.uk or in a European Research Mobility Portal, search Marie Curie Early Stage Researcher position. Then you can find it. There are many projects in Europe. For example, in our group, we have a project called Aquasense. Last year, 2 years back, we advertised it. There are 15 vacancies because in that project, almost 10 countries are involved. So in 10 countries, 15 students are distributed. So you can see that after master degree, you can join in such a project and you will get a very good salary. Plus, you can support your family also to bring here. So during my PhD degree, I bring my family to Poland, and family allowance are there. Many opportunities are there in that. Another is called individual fellowship, like DAD or Commonwealth fellowships are there. And then after master degree, you can join like a many research position like engineering position or a junior engineer, or many opportunities are there plus fellowship. Okay, now as I mentioned you in this topic, what is that topic, how can we choose that topic, that is very important. Okay, um, this is from my experience. I learned this thing. Initially, because after a master degree I applied for a PhD position, nobody replied me. Okay, I didn't get a good position initially. There are many rejection also. It may be due to there are very good candidate, which is very good candidate than me. So they got it. It's natural. So we need to be that good candidate to shortlist it or to interview. For that, you need a very good master degree with a very good score. Why good score? Or normally we say that okay, just pass enough. But when there is a competition, when 2 to 3 members are there, all are in a almost same master degree, same project experience, then the interview panelist or shortlist panelist may confuse to whom I can shortlist. So they will check what is the additional, what is extra in that person or in that CV. So maybe your good score in your master degree may help there, like a distinction or a first class help there. Okay. Other than that, the major important parameter is your master degree project. So we know that in during master degree, in majority in back in our place, I know personally because I normally I did my master degree project under the end of the master degree course. So we need to finalize. We have a lot of exam also. So we need to finish our course as soon as possible. So we did our master degree project in a majority of them in a hurry. Okay, do it very fast. Do it very fast. And after master degree, after we complete after Viva, the majority of us looking forward to get Viva score only in master degree project. Then we stopped it, and then we search for a PhD position and we send application, but nobody is replying. So imagine that there are master degree they completed and along with the publications. So just imagine if you come with a master degree with a small project without any publication and a person come with a number of publication, who will get? So start a very good research in your master degree. This is my major point to all of you. From my experience, I learned. Beginning of your master degree, try to speak with your supervisor, try to speak with your teachers. Start your project as soon as possible. You don't need to spend all time. You can spend 1 hour in a day or half an hour in a day. Read research articles. Majority of our problem is that we thought that, okay, research is very difficult. See, I'm coming from a very background family. Okay, I'm coming from a small village. I'm still learning. I'm not reached any height. I'm still learning from my experience. Initially, I did not read. I don't know anything about any research article during my master degree. Maybe you know, but in my master degree, I didn't know anything about research article. But if you can start learning a simple a paper, a publication, you will get many ideas. Because you see, we are rich with the resources, especially in Kerala. We are rich with the resources. We have a lot of ponds. We have a lot of natural fibers. Many things are there. You can start your any research. I don't say, I'm not saying that you need to start in methyl oxide, you need to start in polymer, or you need to start in chemistry. Any research you can start. For example, in a normal fiber, you can try to make a electronics using normal fiber. You can make a resistor, or you can make a conductor, and then analyze it. Major important is, see, for example, you have a very good teachers, which they have already doctoral degree, so they can easily help you analyze it properly and make a very good publication based on that. At least a journal article in a national journal article. So in your CV, you are increasing your CV, and there are a lot of opportunity for you to present your work. You see, especially in a COVID situation. I'm very happy. See, there are many webinars or many online conferences. Only you need to find some conference fee. You can present your work. Royal Society of Chemistry promoting many poster competition. Okay, so you can upload your work. You did a master degree, you did a project, and then you can upload that poster as a poster or a oral presentation. See, if you are completing your master degree at the end of your master degree time, you will not get enough time to present all this work. Because we need to make a family, or no, we need to get a job. Many of us are thinking about get a job very fast. So we don't have enough time to look for that project after that. That's I told you. If you can start a master degree, if you joined a master degree, start early. You can easily present in many work. And there are many public engagement activity like Science Day now. You can present your work in a Science Day like in a public or in a school. You can go there. You can present, you see, I made this device. I made a solar cell. I made a solar cell, or I integrated a solar cell in a home, like a small home, like a toy, any home you can make. And then, okay, I powered that. You see, this is a new concept. Promote. And if you got a presentation award, like any award, that will again helpful for you. And after master degree, again I'm saying, if you didn't get any PhD, don't worry. Start a research like in a CMET or in a CSIR laboratory. Many places there are project vacancies nowadays. In UGC allocate many money for grants also. There may be some project vacancy. You can join in a project. You can get experience. For a Marie Curie, less than 4 years of experience is very important. And prepare a very good CV and a cover letter. And start applying. Start looking for the area. For example, if you did your master degree, when you are approaching a professor, okay, I want to do a PhD, then the question will come, in which area? What do you expect? So you need to tell, the student need to tell, okay, see, professor, I would like to do a PhD in a solid state material or in a particular material, in a particular topic, because I saw your experience is matching with this. So then that professor, okay, he know the subject, or he looked the subject, he studied the subject. So he may be very useful for me. So for that, you need to be a very good knowledge in your project, your topic. It's very important also. Okay. And then start apply. There is a previously one of my very junior, okay, he called me. He told me that I applied PhD position. I corrected his CV and he applied. And he said after 10 or 15 application, he told me, okay, see, Chata, I didn't get this. I'm stopping. I'm looking forward another job. I can tell. I applied more than 300 application to get a PhD position, to get a Marie Curie fellowship. So patience. Apply. If you rejected, don't worry. Apply again and again and again. One day it will come. So if you got, that's a fantastic. 3 years research, you can do your PhD training. You will get a very good training in soft skill, technical skill. Explore different research institute. For example, if you joined in a Marie Curie program, I joined in a Marie Curie program in Poland, but I stayed 2 months in Vienna, Austria, and 2 months in Serbia, and I traveled to many countries in Europe with free of cost. All project will fund. You can stay here, stay there. I got a training in intellectual property in Switzerland. I stayed there. So that's a fantastic opportunity. You will not get this in any other project. Okay. And then multicultural activity. You are mingled with many people. In my project, I have a colleague, she's from Serbia. There is another colleague, he is from Romania. So it's like a mixed culture. You can go there, you can visit their programs. It's a different feeling of experience and international exposure. Excellent salary packages, I mentioned you already. Mobility allowance, family allowance, public engagement activity. You can attend many summer school workshop, depending on your host institute, okay? Team building, food, variety of food, okay? So there is a link I provided here, European Research Mobility Portal, where you can find your PhD position. I am again telling you, you completed your master degree in 22 years or 23 years of age. Okay. In your master degree, along with a very good research article, with a award you don't need it's not important to get an award. Okay. I'm saying that it's an additional point. You can easily search. And you can join in your after just completed your master degree itself. So Bartholomew, I'm telling to you, okay, you can check this. If you have very good experience or project experience, just completing master degree, you can join in these programs, because that is the basic background. Okay. And search, if you are completing bachelor degree or starting master degree students, please think about a very good project that will really help you. Not only in Marie Curie, in any other project. Currently there are many issues after COVID, financial issues. The competition is very high now. So you need to be a very good competitor. For that, you need to be a very good background in your CV. Here is my friends, colleagues. Started with a PhD in Poland, and the first row you can see she is my PhD supervisor. She is my mother, and she was helping me a lot. And luckily, with their support, I am able to finish my PhD less than 3 years. Actually, in 2 years and 8 months, I submitted my thesis. Then that will be that was a fantastic opportunity in Marie Curie program. And then these are my current members. Professor Dahya is there, and then my colleagues. And thank you. If you need more, you can visit my website also. There are a lot of information. If you are planning to apply any PhD or a master degree or a postdoc or any help you require, you can contact me anytime. Namita know my Gmail account also. Maybe always this email ID may be not present there, but my Gmail ID is always personal email ID is there. Always. Any help if you need, you can contact. Yeah. Thank you.
Thank you, Libu. That's a question from Bartholomew itself. Question is, in Western countries, we have master's courses in electrochemistry, various specializations. Can you please share any ideas for starting a course in India on MSc electrochemistry, specialized in biosensors and supercapacitor applications?
For starting course in India on
Course in
MSc
India.
electrochemistry specialized in biosensors or supercapacitor application. MSc in electrochemistry specialized in India on I don't know in any university which providing master degree in electrochemistry, particularly in electrochemistry, you need to check. But I know Sikri lab is there in Tamil Nadu. They have very good electrochemistry group is there. There are many research laboratory, they have very good master degree courses, master degree projects are there. For example, in university, in your MG University, there may be courses related to electrochemistry or projects. I know there are a lot of energy related program. There are many related master degree projects are there. So you can join with there in electrochemistry project. Especially, see, when you are doing your master degree in chemistry, you don't need to separately join in that course. You are learning this electrochemistry as a part of your master degree or a bachelor degree physics. You can start your individual project with the support of your supervisor, research guide. So you can complete in MSc chemistry itself a project in electrochemistry area. Okay. For example, ICER Trandram. There are various work is going on electrochemical senses. You can join, you can check any opportunity there in the projects, or you can collaborate during. I know that when I did my master degree, I collaborated with the NIT Calicut to do my master degree project. So you can collaborate master degree project courses. And also there are some exchange programs. Okay, some exchange programs are there. I think there are exchange programs like the Commonwealth. You need to cross check. Maybe you can stay outside in a European countries for a few short period of time to do your master degree project or some exchange program. Especially for a PhD degree, I know there is a Newton exchange program is there, and you can do you can stay during your PhD time almost 6 months in Europe, UK. Any questions?
I think no more questions because students are so expecting some simple level. It is high level for them, I think.
Excuse me, sir. Shall I ask you a question?
Yes.
So you have Sam Sharon.
Okay. Okay. Please.
So you told that in supercapacitors we can use electrolytes like phosphoric acid, etc. But in lithium batteries, I think we can't use a protic solvent there. Option
Yes.
one, you can use ionic liquids or RTI, also room temperature ionic liquids.
Yes.
But I think that for the same reason, battery studies cannot be done in local college environment. But I think supercapacitor, in the case of supercapacitor, it's possible for us to have studies in college level too.
Yes.
Am I correct, sir?
In college level.
Yes.
Yes. You can use.
Because
You want
RTLs are very expensive, and for lithium batteries, especially the condition dry rooms extra needed. No.
Yes. See. Sure. You asked Sharin, eh?
My name is Sharin.
Yeah, Sharin. See. Nowadays, because I got a lot of contact, so they are started their research laboratory in colleges. Okay, as a UGC program. So one of the major topic is supercapacitor. You can start the studies in college level, because why supercapacitor? I am promoting supercapacitor because of the material, the importance of the material itself. Electrolyte. You don't need to use lithium-based electrolyte. Lithium-based electrolyte you can use like a hybrid supercapacitor or a battery type supercapacitor to get a very high performance. Okay, but in many electronics application, there are many ionic liquids. Okay, maybe it is expensive, and also you can prepare your own electrolyte. You can think about new electrolyte. There are many electrolytes which is presented. Recently, I am one of my work is now soon. I'm writing that work. So I compared 4 type of electrolytes there: acidic electrolyte, alkaline electrolyte, and neutral salt based neutral electrolyte, and also an ionic liquid. So there are many review articles also recently presented. Solid electrolyte, for example, Professor Suresh C. Pillai, you know, maybe.
Yes,
So
sir. Yes, sir.
yeah,
Sorry.
they are recently reported one review article in Advanced Energy Material talking about solid electrolyte. Okay, so you can cross check that. There are some review article in chemical reviews, and normal electrolyte like many different type of electrolytes are available. And cost wise, what do you need mainly that you need an electrochemical workstation. Okay, so like a CV analysis or a GCD analysis, galvanostatic charging discharging, an electrochemical workstation, if you can afford that, or if you can, because that is very important.
Yes, at least we're trying to have a CV machine.
Yeah.
Supercapacitor studies, I think we can do, right?
Yeah, super
Okay.
studies you can do that using as you need that equipment, because see, what you need mainly when you are starting a work. Okay, you need to think about four major aspects. One, technical aspect. Second, economic aspect, social aspect, because we need to think about technical, how this is important, how this leads to new work. So you can start with many material. So when you start with a metal oxide material to fabricate your supercapacitor in your college, you need to study mainly its structural property, its morphological property, its electrical property, and then electrochemical property. If you need to apply for a wearable application or an application, an integration level also. So I know it is maybe very difficult to get a
Really,
SEM
sir,
in our
it is.
college, but you can easily collaborate with many institutes are there in CSIR laboratory. I came to know that in Kochi there is a super fab lab is also a startup is there in recently. And they are a fantastic laboratory there, in many tools are there for you to easily collaborate with them or easily ask a help or support. So when I started my work initially, I even though in Poland also I don't have that SEM in my laboratory, so I collaborate with another university. So we can collaborate those studies. You can easily collaborate to morphologic analysis, but that daily you need to measure the electrochemical analysis. That is most important. So electrochemical workstation is the most important tool you need, and the fabrication. If you are fabricating a spin coating method, you know spin coater is not costly. You can easily purchase that. For a dip coating also you can
Yeah, of
easily
course we know,
purchase.
right?
So in my opinion, in college level, you can easily start, especially for students to train or a PhD. Think about different type of. There are many requirements still required in supercapacitor. Still, because I'm still trying to get a good, very good material which I can see. When I used them, I know that my devices are not perfect, because when I connected my devices, after few days it is self discharge is the problem. So I need a supercapacitor which can operate almost in more than 1 month. And you see, there are in China and in many countries now, electric buses are there. In our Kerala also, we have now electric auto, electric scooter. So they need a hybrid energy storage devices. So there are requirements for charging station. You need to charge it within 30 seconds or within 1 minute. A full battery. Supercapacitor is there. You can charge it in less than 1 minute. But you need a very good material to store a huge amount of charge for a long time. So think about material. If you are thinking about a flexibility, you need a flexible material, flexible substrate, biocompatibility. All these parameters are very important. Especially we are looking forward a sustainable system, sustainable environment. We don't want to use a toxic material. So you can research on sustainable materials also.
Thank you, sir. Thank you so much.
Sir, I have a doubt.
Mm.
You told graphene is hydrophobic in nature.
Yeah.
And then how you convert the graphene to hydrophilic by making it a foam,
There,
graphene
there
foam?
are a lot of method like a surface morphology, surface property you can change. There are many methods, and also you can what I did that I coated with a third material like a silver or a graphite polyurethane. So there are many methods nowadays using to convert that hydrophobic nature into hydrophilic. I did printing on surface, a rough surface material. So my graphite polyurethane is a rough surface material. So easily it will interact with electrolyte.
By incorporating some metal oxide, say some example nickel.
Yes, you can incorporate with some metal oxide. That will give you very good performance because metal oxide have pseudo capacitance. Okay, so to enhance your capacitance, you see, you need to enhance two parameters to enhance your supercapacitor performance. One is capacitance, another is voltage. As Sherin asked, of electrolyte influencing on the voltage. Pseudocapacitance, material influence on the capacitor point of view. So you can choose different type of material.
Okay.
Investigate a new material, investigate their property, how they are giving the performances. How can you structure? How can you get a more surface? For example, the most important point is electrochemical active surface area. It's not like our normal surface area. Maybe you are fabricating a 5 centimeter square devices. But in that 5 centimeter square, when electrolyte comes in contact, the active surface area may be very less. So you need to modify your material. You need a very good porous material. So you need to check your porosity and surface properties of material. Sorry, surface to volume, that nanomaterial structure. So all this gives a very good network. And also there are recently Maxine is promoting, and also there are many material 3D layered structured material also you can use. And think about the material specific capacity, theoretical specific capacity. When you are fabricate your device, if this material is good theoretical specific capacity or not, then you can start with those material and then further improve your material properties by using different technologies.
Okay, sir. Thank you, sir. If participants have no more queries, then we will conclude the session by seeking vote of thanks. Over to Sharon, miss.
Good afternoon. Sorry, good evening, one and all. First of all, let me thank you, Dr. Lebu, for your excellent presentation today. So you managed to deliver a fascinating lecture. But the problem is that the student, I don't know, the majority of the attendees are students. I don't know to what extent they were able to understand the topic you have delivered. That may be the problem. That may be the reason for the lesser number of questions. Anyway, I can't. I have no words to explain your attitude towards the buds about to grow. Huh? Actually, you have given a wonderful session. You have given idea to students how to work up, how to grow, and how to come forward. Even to the BSc students also, what are the opportunities we have? Actually, we teachers, sorry to say, we are unaware of all these things, no? So persons like you are giving this much to students. The participants, number of participants is very low. I don't know why the students are not getting attracted towards this type of problems, because they don't know what is happening in this platform. They are unaware of the things. That may be the reason. First of all, let me
Maybe
thank you,
can
sir.
I add you one more thing?
Yes, sir.
Can I add you one more thing? See,
Yes, sir, please.
I just want to add one more thing. See, maybe
Yeah.
if there are some students are sitting here, okay, I receive many CV, okay, I ask, okay, could you please help? So in that CV, I noted one point, because there are a lot of webinars now, attendance of conferences, attendance of webinar. So student mentioning those things, but what I'm saying that attendance is not important. Attendance is important to get the knowledge, but you need to present. So maybe we can promote our student. Many conferences are there in the world. Maybe with you can check with their cost or free of cost also.
Yes.
So you can present your work in a wide community. That is very important. I forgot to mention the student. So try to present in many conferences. Try to present in many national, international, whatever the online opportunities. If you saw, okay, that's very important.
Thank you, sir. Let your
Sorry,
wife.
Miss. I come interpreting.
No problem, sir. Thank you so much, sir, for your vibrant lecture, for your inspiration to your students. Thank you, sir. Now, I also wish to express my gratitude to manager and our principal for providing us this opportunity. And I'm also grateful to IQAC team for the technical support. I'm happy to express my sincere thanks to Dr. Apsara AP, HOD, for her timely suggestions. Actually, we are indebted to Dr. Namita, the organizing secretary of the seminar, for making available such a wonderful resource person today. Our students are definitely indebted to Dr. Namita. I'm sure that she'll help us, not only the students, but our teachers also, to come forward. And last not the least, I'm grateful to the attendees because without them, this is not going to be a success. All the very best, sir, for your future work. All the very best to all the students present here. Thank you, one and all. Thanks again. Bye. Thank you.
Thank you, Miss. Thank you, Namita, for inviting me.
Oh, you're welcome. You're always welcome to such a wonderful session.
Thank you. So, bye now. If you need any help, please contact.
Definitely, we will look forward to collaboration. Okay. Okay. Thank you. Thank you.
Yes,
Thank you.
thank you. Bye.
See you.
വീണ്ടും കൊടുത്തില്ലേ ഫീഡ്ബാക്ക് നമുക്ക് ചെയ്യണ്ടേ സർട്ടിഫിക്കറ്റ് അല്ല നിനക്ക് ഓർഗനൈസിംഗ് സർട്ടിഫിക്കറ്റ് വേറെ ആണോ ഞാൻ ചോദിച്ച ഫീഡ്ബാക്ക് ഷൈജു സാറെ ഫീഡ്ബാക്ക് ഫോം കൊടുക്കണോ അല്ല ആരുടെ